Good evening, children. Welcome to today's chemistry class. We have completed our first chapter, periodic table and electronic configuration. Let me believe that everyone has learned well and completed the notes based on it. Today we are going to start our second chapter. This chapter is divided into two modules. First one deals with behavior of gases and some important gas laws, and the next one is about mole concept. Let's start the class. Compared to solids and liquids, gases have a lot of characteristic features. Many elements and compounds are seen in gaseous state, and we are handling so many gases in daily lives, industries and laboratories. Let's recall the arrangement of particles in each state of matter. In solids, the molecules are very closely packed, hence it has a definite shape and a definite volume. In the case of liquids, the force of attraction between the molecule is very high when compared to that of gases, and it acquires the shape of a container in which it is taken. In the case of gases, the molecules are far apart. Look at the statements given in your textbook. Each gas contains numerous minute molecules. When compared to the total volume of a gas, the real volume of molecule is very less. As you know, the molecules of gases are too small. Here, the molecules of gases are always in a state of rapid random motion in all directions. Random motion means they are always moving. During the rapid motion, the gas molecules collide with each other and also with the walls of the container. This accounts for the pressure of a gas. So what do you mean by pressure of a gas? It results because of the collision between the molecules and the walls of the container. Next point, as the collision of molecules are perfectly elastic in nature, there is no loss of energy. That means, here the energy loss doesn't take place as the molecules has an elastic nature. And the last point, there is no attraction between the gas molecules and with the walls of the container. As you know, the gas molecules are very far apart from each other. Hence, the freedom of movement is very high. On the basis of above statements, can you complete the table 2.1 given in your textbook? The energy of gas molecule is very high. And what about the distance between the molecules, freedom of movement of molecules and attractive force between the molecules? Try to do it. On examining these statements, you may get an idea of volume of gases, pressure and energy of gas molecules, right? These are the factors that affect the properties of a gas. Let's see each terms in detail. First one is volume. What do you mean by volume? Volume is defined as the space occupied by a substance. In the case of gas, it is the volume of the container in which it occupies. See the question given in your textbook. Even if a liter of liquid is transferred into a container of any size, there is no difference in its volume. If a gas which is kept in a cylinder having a volume of 1 liter is completely transferred to another 5 liter cylinder, then what will be the volume of gas? You all know that there won't be any difference in the volume in the case of a liquids. But if a gas is kept in a cylinder having a volume of 1 liter is completely transferred to another 5 liter cylinder, the final volume will be 5 liter, right? Now see the experiment. Pull the piston of a syringe backward. Press the piston after closing the nozzle of a syringe. What happened to the volume of air inside the syringe? See this experiment. Here, a balloon is inserted inside a syringe. Now, the piston is pulled inwards. What happened to the balloon? It doesn't compress because The air escapes from the front, keeping the atmospheric pressure same. Now, press the piston after closing the nozzle of a syringe. What do you observe? The balloon compresses, right? Because the atmospheric pressure inside the syringe increases as the nozzle is closed. Understood? The next one. The molecules of gases are always in a random motion. As a result, what happens? The gas exerts the pressure, which is called the pressure of a gas. If we know the force exerted on the surface and its surface area, we can calculate the force experienced per unit area. That is pressure. The force exerted per unit area is called pressure. Clear? Now, see the motion of the gas molecules. What is the energy gained due to the movement of molecules? Is it a potential or kinetic energy? As you know, when a gas molecule is heated, the temperature is increased and the movement of molecule increases. Hence, the kinetic energy of molecules also increases. So, how can you define the temperature? The temperature is defined as the average kinetic energy of molecules in a substance. Is that clear? Temperature means it is the average kinetic energy. So, what are the factors affecting the properties of gas? It is volume, pressure, and temperature. Let me define once again. What is volume? Volume is the space occupied by the molecule. In the case of gas, it is the volume of container which it occupies. Then, pressure of a gas. When the molecules of a gases are always in a rapid random motion, it exerts a pressure because of the collision between the molecules and the walls of the container. Third one is temperature. It is the average kinetic energy of molecules in a substance.